This experiment is about completing a formal kinetic study of a second-order reaction. The reaction in question, hydrolysis of malachite green, is second-order. While direct study of second-order reactions is possible, a common approach is to impose pseudo first-order conditions. This means having one of the reactants in much higher concentration, so that any change in rate is only due to a change in concentration of the lower concentration species. This means in practice that we can make the following simplification. If the rate of a second-order reaction between malachite green, Mg, and hydroxide ions, OH- is given by this rate law, then in excess concentration of hydroxide ions, we can say that the rate of reaction is simplified to the pseudo first-order conditions, and hence is given by this rate law, where K' is the pseudo first-order rate constant. Comparing the two expressions, we can see that K' is equal to the product of the true second-order rate constant K and the initial hydroxide ion concentration. This itself is a simple linear relationship, and hence a study of the scale of the pseudo first-order rate constant with respect to hydroxide ion concentration will yield a linear relationship whose slope is the true second-order rate constant K. This approach, imposing pseudo first-order conditions and then determining second-order rate constants, is a very common one in experimental kinetics. We can easily deduce the pseudo first-order rate constant as described in the manual, that is, observing the absorbance changes of malachite green, absorbance acts as a proxy for concentration, as a function of time. According to the first-order integrated rate law, a plot of the natural log of this absorbance against time yields a pseudo first-order rate constant for that concentration of hydroxide. Subsequent varying of hydroxide ion concentration means that we can elicit the true second-order rate constant. We can then easily complete this as a function of temperature to also derive Arrhenius parameters for this reaction. This slide then summarizes the data that will be collected and how we will begin to analyze it. We will pick this up in more detail in the post-lab video.